Hello and welcome back to the Rage Racing YouTube channel. Today is going to be a fun one. So we are going to discuss ladder bars versus four links. So up to this point we've discussed how to find the center of gravity in your car from front to back, left to right, and even the height of the center of gravity. If you missed those, go ahead and go back and watch those videos. Previous to that, we talked using the physics of vectors and some applied forces as to when a car might be getting to the point where it's going to have a 100% weight transfer to the rear end, causing a wheelie. We're just going to talk a little bit about how the forces work in a ladder bar versus a four link, and how that relates to the center of gravity of the car that we found in the last video. All the thanks have to go to Dave Morgan for the content of this video. If it wasn't for this book, Door Slammers, the chassis book, I definitely wouldn't be able to present this information because I did not know this information before I bought this book. Now I got this back in the 90s, and if it's still available, I would highly recommend getting it. There is so much information in this book if you want to get serious into drag racing a door slammer. So first of these two suspension systems, on top I have the ladder bar. The ladder bar is a much older design, older style, simpler technology, and some say that it is a more violent reacting suspension when it takes the application of torque. So let's look at the ladder bar. So what we have here is we have the tire, and from our perspective the tire is going to turn counterclockwise. In the center here is actually the axle tube, and welded to the axle tube is the mounts for the back half of the ladder bar. Now the ladder bar itself, this A-frame section, is all welded solid, has no moving pieces. The only part that can possibly move is the front, where it attaches to these like eyelets in a very sturdy bracket that's attached to the rest of the car. So the rest of the force is applied to the from the ladder bar, as far as how it pushes on the car, is going to go through this point here. And you see it has very simple adjustments. There's usually just 2 or 3 or maybe 4 holes that you can adjust the ladder bar to, as far as where it's going to land and where it's going to apply that force to your chassis. And we're going to talk a little bit about that. So with this setup, if the tire is going to turn counterclockwise and we apply force to the drive shaft and to the rear end is going to want to travel clockwise. So let's say we're at the starting line of a drag strip, the light turns green, and we smack the throttle or release the trans brake or dump the clutch. The very first application of torque to this style suspension is going to want to twist the whole axle housing clockwise as it tries to rotate the tire counterclockwise. So if the ladder bar is all solid and connected at this point here, the first initial reaction and force is going to be a force applied straight up at that point. So what does that do? Ladder bar is going to want to rise up and push directly upwards on the car. There's going to be equal reaction as far as wanting to push the tire down. And so what that does, it's called planting the tire, and it's going to just put a whole bunch of like force into the tire. The tire is going to grab as much traction as it can, and from there, hopefully you keep traction, you can launch the car. Okay, so what happens next after that initial hit? Well, now the car is going to start moving forward. Like I said, all the forces are going to act through the ladder bars onto the car and the rest of the chassis through this point right here. And you can change that point, but where we're at now is on that bottom hole there. First initial reaction is going to be up as a reaction. The ladder bar is going to want to try to push up. Since it's solidly mounted, it actually pushes the tire down. And then after that, it's going to want to push the car forward. So it has a force going forward at that point. So we got a point on the car, which we have two separate forces acting at the same time but in different directions. So if you watched my previous video about gassers and why they make wheelies, we talked about vectors. Well, this is another vector. So let's kind of finish our vector here. Remember, we connect and finish off our rectangle. We come up from this point here, go to this point here to finish it off. So this angle here is going to be the resultant of these two forces of the rear end wanting to twist up and the car wanting to be pushed forward. The resultant of both those forces is going to be a force on the car once it starts rolling, kind of on the chassis going up in this direction here along that angle there. So the 4Link is a much more modern suspension system. It's much more complex, much more tunable, which could be good or bad depending on your situation. But there's we'll see. There's a lot of advantages to the 4Link system, and you'll understand why most modern racers use that versus the ladder bar. So right off the bat, you can kind of tell that the ladder bar is a lot longer and takes up more space as far as room in the wheel well housing versus where it's going to attach in the chassis. Where the 4Link, nice, short, compact. You can fit it in more places, so that's one obvious advantage right off the bat. Second advantage, you can see there's all sorts of little holes here to adjust these bars, so obviously it has lots of tuning capability. So that could be as well an advantage. But ultimately, we're going to go back and forth and just kind of see how both of these suspension systems work in the car. So the 4Link, just like the ladder bar, has mounts that are directly welded to the axle housing, and those mounts usually have multiple holes for adjustments, and the front mount where it attaches to the chassis, and again that's where all the forces are going to go through the car, through the chassis, through this mount here. There's lots of holes in that mount as well, and so that gives us all sorts of tuning options as far as changing where these bars go, and you can change the angles and all sorts of stuff as far as where the forces are applied, how the rear end's going to react. There's just books and books just on the complexity of all that. We're not going to go that far. We're just going to talk very generally about the 4Link system. So again, if our tire is turning counterclockwise, the axle housing is, just like above, going to want to turn clockwise right at the initial hit of the throttle, right? Okay, so we're going to, for just the sake of argument right here, of course the ladder bar, which is solid, all welded together, these two bars come together to a very specific point, which is right there on our front mount. You can tell that the 4Link has two bars, again they're angled, but they just kind of end and stop. If these two bars at the angle that they're at, if they would have kept on going, they would eventually connect at that spot there. So that's called the instant center. So let's just take all the variables out and say that the instant center is exactly the same where it lands on the car between the ladder bar and the 4Link. Well, you would think then, right off the top of your head, that well, maybe the forces applied would be exactly the same. It'd be a big jump and straight upward force. Then eventually, as the car got moving, just like our ladder bar, we'd finish out our vectors that way. Well, since the instant center is exactly the same, you wouldn't be exactly wrong for thinking that way, but it turns out that it does not react like that at all. So right now we're going to erase my blue lines. I just want you to understand that where those bars would meet up would have the same instant center as the ladder bar. So in theory it should be the same, but let's watch how some of these forces react. So as the rear end, the axle housing wants to rotate clockwise, instead of just doing what the ladder bar does and just apply a whole bunch of force going straight up into the chassis at a vertical vertical line, it actually wants to do a couple different things at the same time. So first of all, if the axle housing is rotating, wanting to rotate clockwise, it wants to pivot like this. So if it's pivoting this way, it's doing two things. It's pulling back on the upper bar. It's also pushing forward on the lower bar. So we're going to draw back in. I'm just going to use dots this time. I'm just going to draw back in our extension of where these bars would land as far as where the instant center is going to be. I hope these dots kind of come out. Hopefully you see that. And we'll see that's, again, our instant center where they would connect would be there, kind of the same position as the ladder bar. But since you got the way the rear end housing is wanting to twist and pull on the upper bar and push on the lower bar, we actually have two different forces again acting on our instant center. So this bar here wants to pull this way. So we'll draw a force, again using the lines for our vectors, going that way. And this bottom bar does want to push forward that way. Okay, so again, what we have here on this instant center at this point is two different forces acting on the same point at the same time. So let's draw our vectors again and see kind of what we got. So we'll take from this point here, like that, give or take, and this has come up there. Just hand drawn, but this is just, again, more just get the idea of what's happening. So then we have a force that goes like that. So drawing these vectors, if you can kind of see between this point and we complete our vector with our diagonal, this line here, and the length of the line matters, would be what would happen during the initial hit of a four-link. When you first smack the throttle, release the trans brake, dump the clutch, the rear end housing is going to want to twist. So the top parts want to go back, bottom part wants to go forward. So we represent both of those lines of force through our upper and lower bars. And then the way it acts on the instant center is going to be the same thing. So the first initial hit is actually going to be up and forward just a little bit, but it's a very small angle. At the first, very first instant of application of torque. A lot different than the ladder bar, wasn't it? So right off the bat, we can see that the ladder bar is much more violent as far as how it applies torque to the ground, as far as driving the rear tire into the ground and then moving the car. So is the ladder bar better then? Well, it might be for certain applications, but let's just keep looking at the four-link. One thing is the very first initial application of torque, although less magnitude, even though it's smaller, the application of torque does point forward, where the ladder bar, if you remembered, was up only. There was no forward movement of the car, no forward movement of the force at all at the first instant. Then as the car started pushing, we had our forward movement. But the very first action of the ladder bar actually is to go a little bit forward. And after the first whack of the throttle, first application of torque, where the chassis is going to twist and the rear end house is going to try to rotate backwards, now we're actually pushing the car forward. Now it's going to act a little bit more like how a standard ladder bar would, where you have our vectors. So the forces are applied more normally, where you got a lifting force and a pushing force, and in the end, you have something kind of looks a little more like that. So I'm going to draw the center of gravity on this car, and this is, of course, just a drawing, so I hope this kind of works out for what I want to show. But just eyeballing it, let's just say that the center of gravity for this car is, somewhere right around there. Okay, that blue dot represents the center of gravity of this car. So now what we're going to do is we're going to draw a line straight down from our rear axle to the contact patch of the tire to the ground. And we're going to draw a line straight down from the center of the front axle straight down. We're going to draw one straight up as well. Somewhere around there. So the weight of the car is supported by both front and rear on those two contact points to the ground, front tire, rear tire. Of course, we're thinking two-dimensionally. It'll be 4 tires, actually, obviously. But for our two-dimensional image here, just be front and rear. Center of the gravity of the car will be up here. So actually what we do is we're going to draw a line from our center of gravity that intersects at a 90-degree angle the center line of the front axle. So this point here, the height of the center of gravity in line with the front axle, we draw a line from there to our contact patch on the ground, and I'm just going to attempt to draw a somewhat straight line. That's not too bad. So this line here from the contact patch to that point, which is the height of the center of gravity in line with your front axle, is known as the neutral line. Now, if you remember just from what I talked about before, the instant center on a 4-link or the ladder bar is the point of lift on the car. Okay, I want you to watch, just look at this picture and think about these instant centers, 2 different instant centers, as far as the extremes between being in front of or behind the center of gravity. And just look at that as I read this passage out of this book from Dave Morgan. So I quote, since the car rotates around the center of gravity and the instant center is a point of lift, you can see that as the instant center gets further back in the car, it lifts the rear of the car. The further forward the center of gravity, the more likely that the instant center will lift the front. This is a basic element of an early understanding of the control over pitch rotation. A more rearward location is more violent, but is actually lifting less load as it moves away from the center of gravity and the car pitches. Moving the instant center closer to the center of gravity makes it less violent, but there's more load that will be placed on the tire. Remember from earlier readings that there is a relationship to the height of the instant center. As it gets moved higher in the car, the tire gets hit harder. As the instant center location is lowered, the tire gets hit less hard. Therefore, when you start to combine the thinking about front to rear instant center locations with the height information, we start to intuitively relate to a form of pitch rotation engineers call anti-squat. End of quote. So as we know, the height of the instant center, as far as it lays in the car compared to the center of gravity, makes a difference in how the car is going to react, and also how far forward or rear the instant center sits in the car, especially related to the center of gravity, also affects the car. So what engineers have found is this line here, which is, again, called the neutral line. Now, the neutral line, depending on where the instant center hits along that line, is going to change how that car is going to react to torque. I'm going to read a little bit more from this book. So, quote, how this line is positioned in relationship to the line of force that is thrust from the tire through the instant center and on into space helps us predict what kind of pitch rotation we will see. As you know, if you can control pitch rotation, you can manipulate load transfer and with that, traction. If the instant center location is high and towards the rear of the car, it will fall into the area of the car that is above the neutral line. In this case, the chassis will lift and the housing will separate from the chassis. This gives you the maximum amount of chassis separation. If the instant center is located below the neutral line, you can predict that the car will squat. The housing will raise into the car and the chassis will rotate down at the rear end. For those 4-link combinations where the instant center falls right in line of force, the chassis will not pitch rotate at all. It would be like balancing the car on jack stands, except that the car is in a dynamic state. What this means is if you want to hit the tire very hard, choose an instant center location well above the neutral line, also known as the 100% anti-squat line. Placing the instant center below the neutral line will be more accommodating to high torque combinations where less load transfer is needed. Even with the exact same instant center, we know that the ladder bar, simply because of the nature of how the ladder bar works, already hits more violently and hits harder than the 4-link upon that initial reaction to torque. Well, could it be that you could hit the tires too hard? You can plant the tire too hard. You could plant it and it bounces back up. You could put too much force on the tire and you get into the tire shake or something like that. You can apply too much force to the rear end, and then as the back end lifts, then you lose traction, because if the back end, let's say, violently comes down, well, there's going to be an end to that suspension travel, right? So back end comes down, hit the end of that travel. Well, now you've got momentum of the back of the car coming up. What happens when you top out the shocks in the back rear end, the tire? Well, then now you're unplanting the back of the car and you lose traction. So you can hit the rear end too hard. So with the 4-link not hitting as hard as the ladder bar, that actually works to our advantage in a really high horsepower, high torque application. So if there's going to be that much torque coming down the drive shaft, twisting that pinion gear, getting that rear axle housing to twist, there's going to be no shortage of reaction and force to get that chassis separation from the rear end housing to the chassis to lift the back end and to drive that tire into the pavement. There's plenty of torque and there's plenty of reaction to that torque still. Now remember, we do have moving suspension here. We have shocks, the ladder bar system moves, everything's moving. Since we have more torque available to plant that tire. So under a ladder bar, we would plant it too hard and maybe even rebound and unload the rear end and lose traction. Under a 4-link setup, we can control much better that application of torque to the ground. So one of the best things about the ladder bar, again, is the instant centers you could have. There's so many options. You can go high, you can go low, above the neutral line, below the neutral line. You can go, crazy, putting instant centers out here where there's not even any car left. It's that tunability. By moving those links amongst those adjustment holes, changing the angles, changing those angles of, let's say we got the 4-link here, changing those angles, you know, up, down, wherever, you can plot all sorts of points to where that instant center would be, and every one of those points will make the car react just a little bit different. And some of these points are going to land right on our neutral line. Did you ever see those drag cars where they just shoot out? There's like no movement. They just go. Those are probably cars set up with their instant centers set up real close to that neutral line. And just kind of while I'm on the topic for just a very short second, when you are drag racing, you don't want any wasted energy. You want all the energy to move the car forward down the track. Now you have to spend some energy doing things like planting the tire, getting the weight to transfer. You have to spend energy doing that, but overall, that's not energy sending the car down the track. These great big wheels and wheelies and wheel stands we see, that's all just wasted energy. If you notice, your fastest professional cars of today, they don't do wheelies. They'll get 100% of the weight on that rear tire and just skim the front tire on the track. It won't come up. Of course, they got wheelie bars and stuff like that, and there's tuning that has to be done, you know, with those too, with the wheelie bars. But you don't want to waste too much energy doing wheelies, you know, driving side to side, whatever. You want all the energy that you're producing just to go down the track. The leaf spring suspension, I completely kind of glossed over with all of my discussion here. Erase some of these dots, erase some of this. There we go. Okay, so leaf spring suspension. So got a leaf, so you got a shackle here, come down, leaf spring there, kind of comes down behind, you know, let's say on the inside of the tire, there'll be your axle housing. Then you got your leaf spring perch here. Then you got your leaf spring coming up under the perch, coming up. There we go. So this, let's say, is your leaf spring. And there'll be a point there. And the moving shackle back here. So the back shackle moves with suspension movement. The front part is usually like a rubber or polyurethane bushing. The bolt goes through that holds the leaf spring solid in the front of the car. So leaf springs, there's a few things you could do. You could put straps around the front leaves, make them a little bit stiffer. What I ran was just a simple set of slapper bars. Let's see if I can't draw some kind of slapper bar here that bolts to the leaf spring, and you have a little nub here. Sometimes you can shim or adjust that nub as far as how much axle rotation you get before it hits. But the instant center on a leaf spring will be where the spring connects to the chassis, or if you have slapper bars that hit in a different spot, it'll be where that nub hits on the slapper bar. So that's where your instant center is going to be, right there on a leaf spring. So anyways, I'm going to read just a little bit out of this book, and I'll put this up on the screen here so you can see. So it says, for tuning four links. To help you with the tuning relationships, look at it this way. If your car likes more front suspension travel, lighter shock settings, more launch RPMs, more numerical low gear ratio, less tire pressure, or more rear mounted ballast, then your car will like an instant center location above the neutral line. If on the other hand you have evidence the tire is getting hit too hard and the car goes faster when you limit front suspension travel, stiffen the shocks, lower the launch RPMs, decrease the numerical low gear ratio, or increase the tire pressure, you can remove hit and load transfer by placing the instant center lower either on the neutral line or below it. Thank you so much for watching the Rage Racing YouTube channel. If you like any of this content, please subscribe and share with your friends. Coming up on the channel pretty soon should be some Harley-Davidson engine builds, some Harley-Davidson cylinder head modifications as far as porting, installing large valves, flow bench testing, Harley-Davidson dyno tuning, and more Harley-Davidson related content coming up real soon. As far as the automotive side, I do have a small block Chevy race engine I plan to do some work with as far as cylinder head work and assembly. And after all that's assembled, we'll go to hoping to have that engine dyno tuned. We'll see where that goes. And far down the line, we'll be putting in that engine into a car, and then we'll take it to the racetrack with us to see, well, how it does or if it even blows up. Either way, we'll have fun. So thanks for tuning in, and I'll catch you next time.